Hello and welcome everyone. Hi Pawan, hi. How are you? So if my voice is clearly audible as well as I'm properly visible, then write down +1 in the chat box. Okay, is my okay? I got the confirmation. Thank you. I'll be sure. So are you guys excited for today's session? Hi devils. Okay, so whatever your name is. So are you guys excited for today's session? And how many of you have been following this entire series? Hi Ramchandra. So, how many of you have been following the entire series of CodeCamp? So, basically, this is the day 17, and in today's session, I'll be discussing about greedy algorithms. Okay, so we'll be understanding what actually the entire paradigm is. Hi, Mithilesh. Hi, I am new to this. Okay, Abhi is following. Okay, and Devil is also following. Okay, so basically, in today's session, I'll be giving you a broad idea. So, I'll be giving you such a technique that if you follow this technique and whichever question you encounter that will be under greedy paradigm, you'll be actually able to at least get a brute force approach, or you will be able to, let's say, if that question was asked to you in the interview or somewhere else, right? You will be at least able to give them a solution that might partially work, or that can be the brute force approach. Okay. Okay, I can see. Yes, I'm excited. I joined around 6 p.m., but I'm familiar with the basic concept. Okay, great. Okay, so without any delay, we'll start within a few minutes, like 2 to 3 minutes more. Till then, do you guys have any kind of doubt? Do you want me to like? Do you want to ask any kind of questions regarding career or regarding any kind of DSA part? You can write down in the chat box. We'll be beginning at 8:05. Till then, well, let's wait for everyone so that everyone can join and take the best out of the session. Sir, is this will be easy to join session now? I am. Will it be understandable? Okay, yeah, I'll try my best. If you are new to this session or new to DS, I'll try my best that I'll be explaining such that everyone will get the concept and will be able to understand the concept. Okay, I'm unable to recall my concept that I have learned. Okay, so Abhi Gupta says, I'm unable to recall my concept that I've learned. So basically, what I used to follow when I was in college, I was preparing. I used to note down the concept. I used to note down the algorithms, which are standard algorithms, right? And you can constantly keep on revising after like a week or something like that. So revising the concept, revising the algorithms helps out a lot. Okay. Good evening, Shubham. Good evening. Okay, so let's start. So basically, the first part which I'll be covering will be giving you a basic idea about greedy algorithms, how you can think about achieving the workable solution for any of the question that comes under greedy paradigm. So just let me share the screen. I hope my screen is visible to everyone. Okay, I think it's visible. Okay, so first of all, what do you guys understand by the term greedy? Okay, so let's start with the basic thing. What do you understand by the term greedy? It's very obvious. You might have heard about this word very frequently, right? Everyone knows the meaning of being greedy, and we never want to be greedy. So greedy algorithms, we know the general word greedy, that means being greedy means like you want something so badly that you can achieve it like anyhow you want that thing, and you will be greedy, like you will not see the benefits or the thing which you are doing that might affect other people, right? You want that thing, you will achieve it, right? no matter how whatever path you take. So basically greedy algorithm is something like that. Like if let's say this is your problem statement, this is your question, and here is the path that you need to follow in order to achieve the answer. Okay, so basically you can consider this as the problem statement, and this is your solution or the algorithm that will give you the required answer. Optimal option if any step is part of the overall optimal solution. Yes, greedy means selfish. Yes, exactly. Yes, Pratik, you are exactly correct. So basically, if I am giving you a problem statement and I ask you to find out the solution for it, so you will achieve a path, you will follow a path that works greedily. That works greedily means that, let's say, the question says that you have to maximize something, right? You have to maximize the profit, you have to minimize the, let's say, minimize the cost, right? Basically the question wants you to maximize or minimize something. So how will you achieve it? So basically, let's say if the final goal is to maximize the profit, then what you will be doing at each and every point, at each and every certain point or sub problem, you will try to maximize the output. You will try to maximize the output. You will figure out some kind of technique, or you will figure out some kind of repeated thing that needs to be done at each and every problem statement, the smaller sub problems. Sub problem 1, sub problem 2, sub problem 3, and sub problem 4. If you focus on this thing, achieving the maximum or minimum at each and every sub problem, and eventually you will get the finalized maximum or minimized answer for your problem statement. That is how greedy algorithm works. So now I hope this part was clear to everyone. Can I know, was this part clear? What actually means greedy algorithms? A plus one in the chat box. Let's keep the session very much interactive so that everyone will enjoy. Okay, and in between you can surely put down your doubts. I'll simultaneously read down the chat box. Okay, was it clear? Yes or no in the chat box? Okay, I hope it was clear to everyone. So now let's say how to find out the solution for greedy algorithms. Okay, let's say there was some kind of problem given to you, and you were asked to find out the solution, and you somehow figured out that greedy algorithmic way can be applied over here. So basically what you can do, this is your problem statement 1. I'm not taking any kind of question over here in order to explain this thing. So basically, let's say this is your problem 1, and you have to find out the solution for this problem. So what you can do, you will be given input test cases, right? Input test case 1, input test case 2 will be given to you. So you can read down the input test case, and you will be able to figure out that somehow I can understand this input test case 1, and I have figured out that some kind of technique, that is A1 technique, can be applied on this input test case 1, and I'll be getting the solution 1 for it. Similarly, while reading out the input test case number 2, you figured out, okay, so something I was missing in the approach number 1 that I was applicable on input test case 1. Now I have understood that this point is also very much important. Okay, so I figured out a corner test case that this needs to be handled, and I figured out that after algorithmic 1, I came to know that some of the steps were missing, and now I am able to understand that this A2 might work for the other problem. So what you can do, you got the solution number 2. Now what you can do, in order to find out the answer or the algorithm that will work for this problem, you can try out different test cases. Okay, now just give me a minute. I was saying that you tried input test case number 1, and you figured out an algorithm that will give you a finalized solution. And you figured out input test case number 2 had a corner kind of thing, and I came to know that I need to add some of the points to my algorithm number 1, right? And I came at the solution number 2. Now how to finalize that this is my algorithm and this is going to work on each and every test case? So for that, what you need to do, you need to figure out different test cases based on the constraints and based on the problem statements. Try to at least figure out at least 5 test cases. Okay, and now what you can do, you can apply this algorithm A2 on the test case number 1, and you will be able to understand, okay, I can apply algorithm A2 and I'm getting a correct answer. Then you can try out the same thing for the test case number 2, and you figured out a completely new approach is applicable over here. So is your algorithm number 2 not at all worthy? No. It is possible that this can be a corner test case, and you simply need an if else condition to handle this kind of test case. Then you will apply the same algorithm. For now you have two different tools, A2, and for solving test case number 2, you figured out there was A3 algorithm which was only working for test case number 3, I mean the test case number 2. Now A2, you tried out A2 on test case number 3 and it is working perfectly fine. You did the same thing with T4 and you did the same thing with T5. So if you will try to solve the test cases more and more in terms of greedy questions, you will be able to figure out similarities in algorithm, and those similarity will help you to finalize a working algorithm that will be applicable and that will be working on each and every test cases of that problem. So basically in greedy algorithms, if you want to find the solution, try as many as test cases you can. Trying out test cases will be helping you a lot in terms of greedy algorithms. Is it clear? Try out as many test cases possible. As many test cases you can. This is the key to solve questions on greedy algorithms. Okay. After the session, focus on this point, and you can take an easy question. If you are just a beginner, you can try out an easy question and try out as many test cases you can. And mark my word, you will be able to figure out the solution on your own. I'm not saying that it will be applicable for hard questions as well. For hard questions, you need some prior knowledge about standard problems, and standard problems are very much important for learning DSA. Each and every topic has a set of standard problems, and you should verify, you should learn about standard problems, because each and every standard problem will give you different kind of techniques to look at the data structure, and like it will give you a different perspective for the data structure for that algorithm. Okay, so standard problems are the must for each and every topic of data structures and algorithms. Okay, is it clear? Yes or no in the chat box. Is this part clear to everyone? Any doubt till now? Is there a structural way to figure if the greedy solution will work for a particular problem? Like for DP, we look for overlapping subproblems and optimal substructure. No, greedy does not have that kind of thing. That is the reason you need to try out as many test cases you can. Okay, a structured way is this thing, trying out as many. Greedy is, I believe greedy is the easiest paradigm which you can learn very fast, which you can learn very easily. And in greedy as well, everything revolves around standard problems only. Okay, each and every new question will revolve around standard problems, just like dynamic programming. Each and every question revolves around set of standard questions in DP. Over here as well, you will figure out that okay, a variation of standard problem is being asked to me. Confirmation from everyone. I got a confirmation from only Poonam. Wasn't it clear to everyone? Okay, Pratik, I hope I was able to answer your question. Okay. So now let's start with the first question of our session. And as we know that the last question is going to be your homework question, and I'll be discussing the basic understanding of the problem, and I'll be discussing what you can do in order to achieve the solution of it. Okay, so the first question. So let me share the link of this in the chat box, and I want everyone, I'll be giving you few minutes to try to understand the problem statement. And after understanding the problem statement, just write down over here, mention it that I have read the problem statement. Okay, 2 to 3 minutes for understanding the problem statement. Here is the question, and the name of the question is minimum sum of absolute differences of pairs. Try to understand what this question is trying to say. I've shared the link in the chat box. So over here you are given, like, you can read out that there are two different arrays and something needs to be done, that you have to create a pair, right? Try to read the problem statement. The problem statement is not lengthy enough. It is very short and crisp, and not very much difficult language is used. Okay, so now I hope everyone has read the problem statement. Okay, so let's read the problem statement all together. So in this question, you are given two arrays A and B of equal length. Okay, and your task is to pair each element of array A to an element in array B. So you have to make pairs between two arrays, array A and array B, such that the sum of absolute differences of all the pairs is minimum. Basically, you have to make pairs by selecting an element from array A and array B. And let's say you have different m number of pairs. And now what you have to do, you have to select the pairs in such a way that if you take the differences of each and every pair, pair 1 has difference d1, pair 2 has difference d2, and so on. So if you sum d1 plus d2 plus d3 till dm, then that sum should be minimum possible. So that is what the question is asking you to do. Is the problem statement clear? Is the formal understanding of problem statement clear? Yes or no in the chat box? And then we'll understand with the help of a test case. Okay, so let's take this test case, input example number 1, and let's understand over here. So over here, in the first test case, n was equal to 4, and the array elements for A is equal to 4, 1, 8, and 7. And the second array was array B. And over here, the elements are 2, 3, 6, and 5. And what will be the output according to the question? Let's not see the output right now, and let's try to solve this question first. Sorry for the inconvenience about this thing. So now over here, the question says that you have to select an element from the array A. Let's say what a pair contains. Pair contains an element from the array A and an element from the array B. And what you have to do, you have to pair each and every element of array A with element of array B. So let's say you get, for this question, you will be getting 4 different pairs, and you have to find out the differences of each and every pair. D1, D2, D3, and D4 are the differences, and you have to take the sum of these differences. And if you take the sum of these differences, let's say it is D dash, you have to find out, you have to select the pair in such a way that this D dash will be minimum possible, because we know that we can select the pair in many different ways, right? So our target is that. So now let's try to select pairs from this one. So let's say for first pair, I'm selecting 4 and 2. Okay, I'm just randomly selecting 2 this way. I'm selecting in this manner. So 4 and 2 is a pair. So 4 minus 2 will give you 2. 3 minus 1, the absolute difference. We have to take the absolute difference. It will give you 2, and this will give you 2, and this is going to give you 2. So the sum of it, this comes out to be 8. Okay, so we got 1D is equal to 8. That the sum of the absolute differences came out to be 8 by selecting pairs in this manner. So now, what other pairs do you think we can make? What different pairs do you want to select? Anyone from the audience? Write down different pairs which you want to select. Should I go for 4 and 3, or should I go for 1 and 2? Let's go with 1 and 2. Okay, so I selected a pair 1 and 2. Now let's take other pair as 4 and 3. So I selected 4 and 3. Now let's take other pair as 5 and 7. So I selected 5 and 7, and now let's take other pair as 8 and 6. So now let's take the absolute difference. This will be 1, this is going to be 1, this is going to be 2, and this is going to be 2. So the sum will be 2 plus 2, 4, 5 and 6. So I got one more D, and it says 6. So it is lesser than 8, right? I can observe I got a better answer compared to the previous one. So I got D2 as 6. If you keep on doing this again and again, I guess this is going to be the smallest answer. You cannot minimize, you cannot decrease more than 6. Let's check what is the answer given in the output. And answer is the 6, right? The output is given to us as 6. So basically I selected such a pair and came to know that 6 is the minimum answer which I'll be able to get. So this is the pair which is giving me the minimum sum of absolute differences. Is the question clear to everyone? Yes or no in the chat box? Do you want me to take another example? Is the question clear to everyone? Okay. So now, okay, so let's take other example as well so that it will be clear. You'll get a better understanding. So the other input test case contains this. So over here, test case number 2. Input 2 over here, n is equal to 3, a is equal to 4, 1 and 2, and b is equal to 2, 4 and 1. Right? So now what will be the output? Let's try to find the output. So let's take one of the pair as 4 and 2, the other pair as 1 and 4, and the other pair is 2 comma 1. So what will be the difference? 2, 3 and 1. So the sum comes out to be 6. So I got one d1 as 6. So now let's change the pairs. Let's take 1 and 2, and let's take, I took 1 and 2, I took 2 and 1, and I'll be taking 4 comma 4. So what will be the sum? This is going to be 1, this is going to be 1, and this is going to be 0. The sum comes out to be equal to 2. It is obviously lesser than d1, so the output comes out to be 2. Let's check if this is the optimal output. See over here, I'm getting the output as 0. So this is not yet optimal. Let's try to find a better set of pairs. Okay, so now let's try in a different manner. So if you observe carefully, over here you can observe 2 is also present in B and 2 is also present in A. So I'll be keeping 2 comma 2. And 1 is also present in both of them, and 4 is also present in both of them. So this will be giving you difference 0, 0 and 0, right? And the sum of this difference comes out to be 0, right? So the output minimum, D3 is minimum than D1 and D2, and hence output can be 0, it cannot be lesser than 0, right? Because we have the sum of absolute differences. Minimum sum will be 0. Yes, exactly, Shubham. So now what about the approach? What do you think, what can be the approach for this problem? What do you think? How you can solve this? Can anyone say the brute force approach? Can anyone share the approach that you are thinking right now? So try to think how you will select pairs. Over here, the technique or the thing is how you will select the pair. The way you select the pair, it will affect the final sum of differences. Sort the array. Okay, Ohm says sort the array. And what is the reason behind sorting? You are absolutely correct, Om. So what is the reason behind sorting? How will that help us? Okay, we got an answer from Arnidam repeating Pratik's question. Is there a structured way to figure FGD like for DP? Okay, so I already answered that thing. You can just go back in the video and you will be able to understand it. Okay, so Om, what will be the reason behind sorting the array? Ascending order. Yes, exactly. So let me elaborate what Om is trying to say. So basically, he's trying to say that we have to sort the arrays. So let's sort the array and let's understand the reason behind sorting the array. Okay, so after sorting, we get 1, 2, and 4. And for the array B, we will be getting 1, 2, and 4. Okay, so basically after sorting you can observe that if you select the adjacent pairs, adjacent element in both the arrays like 2 2 and 4 4, the absolute difference, the sum of absolute difference is the minimum possible. So this is perfectly working for input test case number 2. So you can take it as algorithm 1, right? Algorithm 1, what you did, you sorted the array and took corresponding element from both of them. So this is algorithm 1. See, in this manner you figured out for this test case number 2, algorithm 1 is working. Now you need to verify this will work for other test cases or not. So now let's sort this array. So this will be 1, 4, 7 and 8. And now this is going to be 2, 3, 5 and 6. So now let's select the adjacent one, 1 and 2, 4 and 3 and 5, 7 and 6, 8. So if you observe carefully, you can observe that over here this is the pair which was giving us the minimum answer 5 and 7 and 8 and 6, and the minimum answer came out to be equal to 6. So this is perfectly working. The algorithm work is perfectly working for this input test case number 1 as well, right? Okay, so now let's try another test case as well, so that we can be sure enough that this is the final algorithm and it will work. So if you will take one more test case, let me take a random test case that is going to be input test case number 3. So let's take 3, 9, 14 and 12. And this is the array A, this is array B. And let's take 8, 7, 4 and 19. Okay, so there are four different values in each and every array. Let's try to sort it. So this will be 3, 9, 12 and 14, and this is going to be 4, 7, 8 and 19. Now let's take the pair 3 comma 4 and then 9 comma 7 and then 12 comma 8 and 14 comma 19. Okay, so this will give you 1 as the difference, 2 as the difference, this will give you 4 and this will give you 5. So the sum is equal to 1 plus 2 plus 4 plus 5, 9, 10 and the sum is equal to 12. Can I do better than this? And if you will argue that why this is the optimal answer, and if I am able to justify it, then this is going to be acceptable, right? So basically if you draw a number line, we know that in the number line, this is how the number line looks, right? It starts from 0 and it goes to infinite and 10. Now on this number line, if you place the elements of array 1 and array 2, so now on this number line, if you place the element of array 1 and array 2, so by sorting, 3 is over here. So let's mark it with white, 3, and I need to extend the number line. No worries. Okay, and let's ignore the numbers in between. Okay, so after 8, we directly have the next number as 12, 14 and 19. Okay, so I'm just writing down in this manner over here 12, 14 and 19. Okay, imagine there are numbers in over here as well. So 3 is the number. After 3, we have 9, 8, then 9, 10, and over here we had 12. And what else do we have? 12 and 14 and 19. 14 and 19. Imagine there are numbers in between as well. So 3 is the number in array A, 3, 9, 14. This is 9, this is 14 and 12 as well. And for the array B, I'm marking it with green color. Okay, so this is 8, 7, 4, 8, 7, 4, 8, 7 and 19. Okay, if you observe carefully, the after sorting, you can observe, see, if I'm taking an element A in pair number 1, pair 1 contains A, and if I want the absolute difference of this to be smallest, then what I can do? I need the closest element to A. If I want the difference of the other element, if I want the difference of a minus b, absolute difference of a minus b to be minimum, then what I can do, I can select a and b as close as possible. If I select 3 and 4, if I select 3 and 4, or if I select 3 and 19, which will give you smallest absolute difference? What do you think? Obviously 3 minus 4 will give you the smallest one. 3 minus 19 will give you 16. So by sorting, each and every number which should be paired to the closest number will be adjacent to each other. Okay, will be closest to each other. So after sorting, this is how you replicate the number line by sorting. So this is the reason behind sorting the arrays. So if you sort the arrays, so what is our algorithm? So algorithm comes out to be that you need to sort both the arrays and select corresponding elements in both the array. In both the array to make a pair. So this is the algorithm for this question. Any doubt till now? Yes or no in the chat box? Any doubt? Do you guys have any kind of doubt? Okay. So now we need to sort the arrays and select corresponding elements. So we can directly move towards the coding implementation for this same. I'll be coding in Java, but as I mentioned the entire algorithm, I guess everyone will be able to code in other languages. You simply need an algorithm and implement it in any of your language, right? So first step is to sort both the arrays. So I have an inbuilt function in Java that says arrays.sort, and it will be sorting both the arrays. So I'll be applying the inbuilt function to sort both the arrays. I have sorted both the arrays. Now the second step of the algorithm came out to be selecting corresponding elements from both the arrays, right? So what I'll be doing, I'll be iterating over both the arrays. And what is the size of both the arrays? Size of both the array is equal to n because they are of same size. Now in order to store some answer, I need a variable, right? So I'll be taking long because it is possible that absolute difference, let's say over here, if you will take the constraint says the maximum element can be as large as 10 to the power 9 and smallest can be as small as 0. Let's imagine an worst case example in which array A contains all zeros and the other array contains 10 to the power 9. Each and every element is 10 to the power 9. Now, if you will take the absolute difference, the sum will be equal to 10 to the power 9 multiplied by 10 to the power 5. Imagine an array of size 10 to the power 5 according to the constraint. So 10 to the power 9 into 10 to the power 5 will be somewhere around 10 to the power 40. And integer data type is not huge enough to store such a very large number, right? So I have taken this data type as long. Now let's take the adjacent element. So adjacent is array of I minus b of I. Now we need an absolute difference, right? We don't know which element is going to be the larger one. So I have taken the absolute difference of both of them and I'll be adding the answer. And at the end, I'll be simply returning the answer. Okay, so let's try to compile and run. And the compilation works perfectly fine. I hope this works. And the compilation is completed. Let's try to submit and see the acceptance. And we can see the problem was successfully solved, right? Over here we would use the same technique, right? I explained that in order to solve greedy algorithms, this technique of trying out as many as test cases will work, and each and every step at each and every test case you will be able to understand that this is the similarity of approach for each and every test case. Is it clear? Yes or no in the chat box? Were you guys able to understand it properly or not? Okay, so if it was clear, we can move towards the next question. So the next question is this one: maximum meetings in one room. So try to read the problem statement. Okay, so the question is like it has many lines of problem description. So try to read the problem statement. I'll share the link of this in the chat box. Okay, so try to understand what the question is trying to say, and try to read down the example as well. So for this, I'll be giving you 5 to 6 minutes. And if you have read the problem statement, just mention it in the chat box. This is one of the standard problem of greedy algorithm. Okay, and a variation of this question like will be asked to you as well. Okay, it can be asked in interview as well. And this is also interview like centric question. It has been asked many times in interview. A very famous question of greedy algorithm. How many of you have completed the reading of the problem statement? How many of you have completed the reading of the problem statement? Okay, so I missed a comment that is Pratik says this approach can also be tweaked for max difference also. Yes, this approach can be tweaked for maximum difference. Okay, yes, you can do that as well. Okay, Pratik has read the problem statement and Shashank as well. And what about the other guys? And for this question, for the previous question, what you can do over here, it is given no that for all the sum of the absolute differences of all pairs is minimized. So if what maximize was given to you, what if maximize was given to you in the other different question? Try to think on that. Okay, so for greedy algorithm you will be able to see that for minimum also you can solve that question, for maximum also you can solve that question. Okay, and whichever is the harder one will be the priority of the interviewer. So we'll put minimum or maximum. And for some question it does not make sense that what is the minimum of profit or minimum of something, right? For some question you can solve it for maximum also and for minimum also. Okay, I hope it is clear. So now it's 8:39. Is there anyone who is still reading the problem statement? And those of you who have read the problem statement, try working on the approach of it. Okay. Okay. Now let's understand the problem statement. Those of you who have not read the problem statement, pay attention over here. Will be understanding together. So the name of the question is maximum meetings in one room, and difficulty level is medium. Okay, so don't focus on difficulty level, just go directly to the problem statement. There is one meeting room in a firm. Okay, so there are n meetings in the room, and meeting in the form of S of I and F of I. So where S of I is the start time of the meeting I, and F of I is the finish time of the meeting I. So for ith meeting, S of I denotes its start time and F of I denotes it end time. So the task is to find the maximum number of meetings that can be accommodated in a meeting room. You can take an example. Let's say in an organization there is a meeting room. Okay, and there are different meetings that needs to take place. You are given time, the starting time and the ending time. It is very much strictly to be followed, that whatever is the starting time and minimum finishing time, you cannot extend or you cannot reschedule the meeting. So what is the task? The task is to find the maximum number of meetings that can be accommodated in the meeting room, as there are n number of meetings, and it is possible that the timings of two meetings might overlap, and you cannot put both the meetings in the same room at the same time. Okay, so the question says we want the maximum number of meetings to be held in this meeting room. So you have to find out what is the maximum number of meetings that can be held in the meeting room. So you can accommodate a meeting if the start time of the meeting is strictly greater than the finish time of the previous meeting. As I mentioned, if the meeting timings are overlapping, then you should be sure enough that the start time of your current meeting is strictly greater than the end time of the previous meeting. That means after the previous meeting has ended completely, then and only then your meeting is allowed, if it is starting after the ending of the previous meeting. Okay, and it is given in the note that if two meetings can be chosen for the same slot, then choose meeting with the smaller index in the given array. Okay, was it clear till now? Okay, we already got an answer from Gaurav. Okay, so we'll not directly jump to the solution part, but let's uh, solve it on our pace, right? So was it clear? Was the formal understanding of the story part clear to everyone? Yes or no? If it was clear, a plus one in the chat box, right? So now let's take this test case and try to understand that how we can achieve it. Now here you can see in the input n is equal to 6, that denotes the number of meetings, and s is the array that says start time of every meeting, and f is the array that denotes the ending time. And in the output you can observe there are some different numbers, 1 2 4 and 5. So what does it mean? So it is the meeting id, I mean the first meeting or the index of the array. Let's imagine the indexing of both the array starts from 1, 1, 2, 3, 4, and 5, and at the end 6. So over here in the output, it has mentioned that which meetings can be conducted and what is the ordering in terms of no such ordering is to be followed, but this is the total number of meetings which we can accommodate in the meeting room. So 1, 2, 4, and 5. So that means the meeting starts at 1 and ends at 2 can be done. 2, that is 3 and 4 can be done, and 4, that is 5 to 7, and 5 is this one, 8 to 9. So this 4 meetings can be held in the meeting room. So let's understand. Let's copy the test case. So here is our question number 2. If you have any doubt in the problem statement, do mention it right now. Okay. Okay, Pratik. So question number 2, and now we were having the test case as this. Okay, so let's, so the test case says n is equal to 6 and the starting array s is equal to 1, 3, 0, 5, 8, and 5, and the other array that is finishing time of the ith meeting says 2, 4, 6, 7, 9, and 9. Okay, and we have to find out which meetings will be held, and in the output you have to put their IDs. So ID will be 1, 2, 3, 4, 5, and 6, or the numbering of the meetings, right? And now here is our, imagine this is my meeting room. Now how will I start solving this test case? We need to understand. So we know that, let's imagine a number line, I mean a number line or a timeline. Okay, and the timeline starts from 0. This is 1, 2, 3, 4. And now over here, let's mention the meetings as well. So the meeting 1 starts from 1 and it ends at 2. So this is meeting 1. And the other meeting starts at 3 and ends at 4. So this is meeting number 2. Over here, everything is based on the time, right? So it is better that we imagine actually how on the number line it looks like. So after M2, this is meeting 3, starts at 0 and it ends at 6. You can observe that this meeting times are overlapping, right? Clearly we can observe. So the fourth meeting starts at time at fifth hour and it ends at seventh hour. This is M4. And what is the fifth meeting? It starts at 8 a.m. or let's say 8 hour and it ends at 9 hour. This is meeting number 5. And the last meeting starts at fifth hour and it ends at ninth hour, right? So this is the last meeting, that is meeting number 6. Now you have to find out that which meetings should be scheduled so that maximum number of meetings can be done right in that room. So let's say if I'm selecting meeting number 1, if I'm selecting meeting number 1, then all the overlapping meetings cannot be held in that room. So meeting 3 has no scope of being held. Okay, so let's say if I'm selecting meeting number 3. Now after selecting meeting number 3, I have an ideal time after 2 hour, right? After 2 hour, I can organize any kind of meeting I want. So this is meeting number 2 because I have the option that at hour number 3, I have meeting number 3. Okay, so I'll select meeting number 2. Now over here, as meeting 2 is being held, meeting 3 cannot be held because it is overlapping. So after the fourth hour, I am completely free. I have the entire meeting room. So I'm selecting meeting number 4. And after meeting number 4, I have it ends at the seventh hour and I have completely free time. So I'll be selecting meeting number 5. If I'm not selecting meeting number 4, let's say over here, what is the total number of meetings which I was able to conduct? I am able to see that 4 meetings were being conducted. That was 1, 2, 4, and 5. Okay, and let's say if I was not going for the meeting number 4 over here. Okay, instead of meeting number 4, what will be what will be selecting? I'll be, let's say I'm selecting meeting number 6. If I'm selecting meeting number 6, I cannot conduct 4 and 5. And over here, what will be the sum of meetings or the total number of meetings that were conducted? It is equal to 3. So meeting 1, 2, and 6 were conducted, right? So I can see the better option is to conduct the total number of 4 meetings can be conducted, and that is the maximum answer. Better than that, I don't think we can do it. Let's try out one more. If I'm selecting meeting number 3 instead of meeting 1, let's say if I'm selecting meeting number 3, I selected meeting 3. So I cannot select any other meeting, not meeting 1 or not meeting 2, not meeting 3, I mean 4 and 6 also cannot be selected. So the last option remains is meeting number 5. So here what is the total number of meetings? 2 meetings, third and fifth. So what is the optimal and what is the maximum answer? How many meetings can I conduct? I can conduct 4 meetings at max, and that is going to be the output for this. Was the question and how to solve it in a brute force manner, was this part clear? Can I get a confirmation? Okay, so Pratik has mentioned 2 different approaches. Okay, Pratik. Okay, so in this manner we can try out different approaches and we can solve a test case. But over here, this brute force manner, this brute force way, if we select this brute force, if we go in this manner, it is obviously going to take much amount of time, right? So what do you think, what can be the approach, or how we can achieve it, how we can reach down a solution? Okay, Pratik has already mentioned the naive as well as the other approach. So I want the answer from other people as well. What do you think? Try to think what can be the brute force approach. Any ideas from anyone? How can we achieve the answer? How can we find the answer? I think we can use previous question approach maybe. Okay, so over here, that was a smart move. So in the previous question, we did something sorting and kind of thing, right? So over here, on which array should I go? Should I sort the first array, that is the array which says starting time, or should I sort the second array? We need to think on that, right? Which sorting will help us? Which sorting will be beneficial? Uh, does there any free certification? Yes, Gaurav, you were correct about the approach which we can take from the previous question. But try to think on which array should I apply sorting, or on both the arrays. Do you think applying both the arrays on, like sorting on both the arrays will be helpful? Yes or no in the chat box. What if I apply sorting on both the arrays? Is it a correct way to do or not? Okay, so Gaurav says sort both the arrays, not on both the array. Okay, so why not sorting both the array? How many of you are agreeing that we can sort both the arrays? I'm not asking the reason or anything. I do you guys have a, do you guys like are thinking in that way that we can sort both the arrays? How many of you are saying that we can sort both the arrays, and how many of you are denying that do not sort? Only on start. Okay. So Gaurav says only on start. And what about the other people? What do you think? So I can understand by now everyone was able to figure out one thing, that sorting needs to be done. Okay. And how were you able how were you able to think about sorting? Because if you draw a timeline in such questions, you will be able to observe. Okay, you can observe that meeting one is being held before meeting two. I can observe overlapping of meeting one, meeting and meeting two, right? So try to visualize the numbers. Okay, if it says it denotes time, try to visualize on a timeline in this manner. So this will help you a lot. Okay, so I got an answer. I think we need zip the list and sort by the end time. Okay, Pratik, we can try out that as well. And Rokya Bhavya says start and end time is the pair, so we can't sort. Yes, exactly. So basically, over here, this both the arrays represent the starting time and the and the ending time of a particular meeting. So this two cannot be placed at any other position. Okay, if this one denotes the starting time of meeting one, then this two needs to be placed at this particular index only. You cannot rearrange it anywhere else, because there is a mapping between the both the elements of array. both the elements of start and the first array. So basically this elements are mapped together. Okay, you cannot interchange them. If you interchange them, then you will lost the data, you will not have the correct data. Okay, yes, exactly, Bhavya, you are correct. Because if we sort both the array, the couple of start and exactly sorting will ruin the array. Okay, so okay, so Pratik said, I think we can zip the lists and sort by the end time. Okay, so we can do that as well. But I need to know from you guys, why are you guys thinking about sorting the end time? What if I sort the starting time? Won't that work? And what is the reason? If you are saying that that will not work, I agree with you. Okay, so without questioning, I will be agreeing. But I want the reason behind sorting the ending time. What is the reason behind sorting the ending time? What do you think? Okay, so what is the reason behind sorting the end time? Okay, end time means current meeting is the first to end. End time means the current meeting is the first to end. There is no previous meeting ending before it. Okay. Anyone else? Why do we need to sort the ending time of the meetings? What if I sort the starting time of the meeting? Let's try out by sorting the starting time. Okay. First of all, let's verify that why should you move in that direction. So over here, what I am trying to do is that sort the starting time. Okay. I'll take the same example, this one. And over here, as a mapping is there between both the elements, what I'll be doing, I will imagine them as a pair. Okay. So you can imagine them as a pair in this manner. Meeting 1 says 1 to 2, meeting 2 says 3 to 4, and meeting 3 says 0 to 6, meeting 4 says 5 to 7, 8 to 9, and 5 to 9, meeting 5 and meeting 6. Now I'm sorting based on the starting time. Okay, so I can see this starts at 0th time, so I can place it over here. And now this will be the second one. Okay, sorry, I'm extremely sorry, I forgot to share the screen. So over here I have mapped the starting time and the meeting time. You can imagine this as a class or anything, as an object of meeting, and that object contains what? It contains the starting time and the ending time of the meeting. Okay, and you can place the id of that meeting as well, that is the index. So I'll be placing three different values: starting time, ending time, and the index. Index starts from 1. So now I'm sorting this arrangement of meetings based on the starting time. So for starting time, I can see M3 as the smallest starting time. Now M1 is the smallest starting time. And now what else? Now I have M2 as the smallest one, and M5. So over here you can observe M4 and M6. So note says that whichever meeting is having the smallest ID should be selected. Let's say you reach a scenario that you have the option to select M4 and M6, right? And both of them are starting at the fifth hour. So you should go for M4. but over there they should have the same ending time as well. So let's say I selected M4, then M6, and now at the end M5. So this is the sorting based on the starting time. So now let's try to understand. So now after sorting, what I will be doing, what, how will I achieve the solution? Now I have sorted, now how should I work on it? Yes, exactly, Pratik. So sorting by start time does not give much information. Okay, so what information is missing over here? Okay, so I have sorted, and now let's say after sorting I'll be selecting sequentially, right? There was some meaning behind sorting. No, I've sorted it, so now I can select sequentially, right? So let's start with M3. I selected M3, and it starts at, I'll be mentioning it over here, the ending time of the previous meeting. So currently my M3 is being held, and it has an ending time of 6. So next meeting can only start after 6th hour. Okay, not at 6th hour as well. So can I go for M1? No, because it has a starting time of 1. Can I go for M2? No. Can I go for M4? No, I cannot go because that value are lesser than the end time of the previous meeting. Can I go for M6? No. Can I go for M5? Yes, I can go for M5. So M5 will be the meeting which is going to be held, and the end time of this meeting 5 is 9. So any value or any meeting which is starting after ninth hour can perfectly be organized. So after M5, nothing is remaining, right? So I can go for this as well. So I will be going with M5. So what number of meetings were conducted? I can see one and two. Only two meetings were conducted, but that is not, we know that that is not the correct answer, right? Isn't it? Take the pair taking less time. No, over here we have to focus on total number of meetings that I can organize. Okay. So if you focus on the duration of the meeting, that is not going to help. Okay. If you focus on the duration of the meeting, then it is not going to help every time. So is it clear that sorting on the starting time is not giving correct answer? Why? Because over here, the main focus is that end time of the previous meeting and the start time of the current meeting. Okay, if I want to conduct a meeting, if I want to currently organize a meeting, then I need to check the end time of the previous meeting. Okay, and then and only then, if the end time of the previous meeting is strictly lesser than the start time of the current meeting, then and only then I can organize this current meeting. So over here, this inequality will be giving you the correct answer, will be helping you to find the maximum answer if and only if you sort the meetings based on the end time, because the end time will be obviously will be lesser than the start time. Okay, I'm sure for each and every pair. So now if you are sorting based on the end time, let's say on the number line, this is the end time of every meeting, end time of E2, E3, let's say E5 is ending over here, E4 is ending over here, and E7 is ending over here, right? So this meeting will be started before this end time only, right? Because we know that the starting time is obviously lesser than the end time. So this is how the arrangement will look like. Okay, so at the end, you simply need to compare the end time of the previous meeting because you have sorted based on the end time. So this part is completely sorted. Now you simply need to check whether the next meeting E2 can be held or not by just checking the end time of the previous meeting. Okay, as we know that the start time is always lesser than or equal to the end time, we can apply the sorting on the end time. So this part will be checked, this part will be done for us, and this inequality part, that is, can I organize the next meeting or not, can be checked by simply doing this inequality comparison. Okay, so that is the reason that sorting on the start time will not work. If you sort based on the start time, let me give you a visualization of that as well. Now let's say I sorted based on the start time. So this is S3, S2, let's say 7. I'm just randomly writing down, okay? So don't focus on this part. And this is S, let's say 6. So now as I've sorted based on the starting time, it is possible, it is completely possible that the start time of one of the meeting can be as long as possible. It can be like, let's say, the it has the largest ending time, right? So this meeting will be clashing with the other meetings as well, and you will not be able to handle, or you will not be able to held any kind of meetings if this S3 was selected, because a start time is bounded by the end time, but from start time we can't tell anything about the end time. Yes, exactly, because if we sort based on the start time, we will not have any kind of idea regarding the end time. If we have sorted based on the end time, we can say that start time is lesser than the end time. So this meeting might have started at a time, let's say this meeting was ending at the fifth hour, then I can be sure that M1 might have started at some time lesser than 5. But if you sort based on the starting time, let's say M1 was starting at R2, then you cannot say nothing. You cannot say anything about the end time. You can simply say that the meeting 1 will be ending at an R greater than 2. But this is obvious, na? Right? And this is not at all going to help me in scheduling the next meeting, because at the end I need to compare the end time as well. Are you getting my point, everyone? A plus one in the chat box if this part was making sense to everyone. Can I get the confirmation from everyone whether this part was clear to you or not? Okay, thank you, Pratik. Okay. So now we can conclude that sorting on the start time is not going to help. So what else other thing? So we had three different options, right? Sort both the arrays, sort based on the start time. And the other option was sort based on ending time. We have three different options, and one by one we can conclude for each and every that this thing is not going to work, this is also not going to work, and now the last thing is remaining, that sorting based on the end time. So we need to verify whether this is going to work or not. So now let's take the same example and verify it. Okay, Pratik. Okay, Shashank, thank you for the confirmation. You guys are attentive, right? Are you all students, or are you working professionals as well? Can I know what do you do? What my audience does? Are you working professional or pursuing, or a fresher? Okay, write down in the chat box. I will write it down. So now this thing, second thing which I was going to do was sort the ending time. Okay, so unrelated. Your writing is beautiful. Acha. Thank you, Pratik. Student. Okay. And what about you, Pratik? Are you a student or working somewhere? So let's get back to this. So I'll be sorting based on the end time, based on the ending time. Career shift, trying to get back into IT, preparing for interviews. Okay, that's really. Don't you guys think that IT is a very like uh, that any non-tech, anyone from non-tech background as well, and those of you who are already in tech, they can obviously get the job in IT. But those of you who are not from non-tech as well, you have lots and lots of opportunities over here, because you simply need to know DSA and just start learning a programming language, and that's the entry level thing which you can do for getting an entry in IT. So everyone, welcome to IT. Okay. Sahil Garg, career shift. Okay. And Rokya Bhavya is working. That's really great. We have a very like, everyone is like thriving to get into IT, and it's really great. And trust me, this is not going to end. Like, IT sector is going to progress a lot. It is going to achieve new steps. Telecom to IT. Okay, Sahil. Okay, so now let's get back to the question part. So sorting based on the ending time. Okay, so let's start sorting. So I have taken this pair where n is equal to 6. There are n 6 different meetings. Now let's sort based on the ending time. And over here, I'm sorting in increasing order of the time, not in decreasing. Obviously, no, what is the need of sorting in decreasing time? Because time does not run in reverse manner. It does not decrease, right? It always increases. So I'll be sorting in increasing order of the time. And which is the smallest, who has the smallest ending time? M1. Let's pick M1. Now the other is M2. Let's pick M2. The other is M3 based on the ending time. And now this is already sorted. Let's pick and place it over here. So now I have sorted the entire meetings based on the ending time. So now let's one by one check, and I will keep one more variable, that is end time, that denotes what was the end time of your previous meeting. Okay, and currently no meeting is there in the meeting room, right? So the end time, let's keep it as -1 or 0, anything. Let's keep it as -1, because for some of the meeting, its starting time can be equal to 0 as well. Okay, so I'm, for safety purpose, I have initialized end time as -1. So now let's pick M1. So when can you pick a meeting? So you have to check if the starting time, if the end time of the previous meeting, that is the variable end time, is strictly lesser than the starting time of your current meeting, starting time of your current meeting, then and only then, if this condition is satisfied, then and only then you will take this meeting to the meeting room. Okay, so now let's compare. So end time is this, end time is -1. And what is the first meeting start time? It is 1. So -1 is lesser than 1. Yes, absolutely. So this M1 can be organized. So I will organize M1. Okay, and if any of the meeting is being organized, then you will update the end time. So end time will be nothing but the end time of the meeting which was organized previously. So 2 will be the end time currently. Now let's pick the next meeting. So next meeting is M2. So let's compare the start time. So this is my end time is 2, and what is the start time? Is 2 lesser than the starting time of our current meeting? Yes. So I will take this meeting to the meeting room and update the end time. So end time will be the end time of this M2. So this will be 4. So now let's check for the next meeting. Next meeting is this one, M3. End time says 4. And what is the starting time of the meeting? Starting time's meeting is 0. So do you think this inequality holds true? Absolutely not. 4 is not lesser than 0, right? So M3 will not be selected. Now moving towards next meeting, so that is M4. End time is 4 and starting time of M4 is 5. So let's see, 4 is lesser than 5. Yes, absolutely. So M4 will be conducted, and let's update the end time to the 7. So end time will become 7 because that is end time of the previous meeting. Now let's check the next meeting. So next meeting is M6. So do you think this is the starting time? Do you think 7 is lesser than 5? No, absolutely not. So skip M6 and go to M5. So M5 says its starting time is 8. So 8 and 7 is lesser than 8. Yes, absolutely. So I will go with this meeting M5 and updating the end time to 9. So 9 will be the end time. So now after this, is there anything remaining? No, nothing is remaining. Now, how many meetings were conducted? Four meetings were conducted. And what were their IDs? Their IDs were 1, 2, 4, and 5. And this is going to be the output. Okay. Is it clear? Yes or no in the chat box? Was this part clear to everyone? What was the process of selecting a meeting? If you want to select a meeting, then this is the inequality that should hold true. If this inequality holds true for a particular meeting, then you can select this meeting and update your end time variable. So was this approach, was this process clear to everyone? Yes or no in the chat box? A quick reply. If you have any doubt, mention it in the chat box. Okay, so thank you, Pratik. So now let's write down and convert this process into an algorithm. Okay, so let's write down the steps of the algorithm. Okay, so what is the first step? First step includes sorting the array, right? Which array? Which array? Finish time array. I have to sort based on the finish time array. So can I directly sort this finish time array and will it work? No. As I mentioned that the elements of both the arrays are bounded to each other. They are mapped to each other, right? You cannot change the arrangement of them or you will lose the data. So what I'll be doing, I will be over here create, you can create a pair, you can create an object, it's your choice, right? So what I'll be doing, I'll be creating an object of every meeting. Okay, I have created an object and what will be stored inside that object, and inside the object I will store its starting time, its ending time, and its index, because in the output we need to print the indexes at which meeting will be conducted. So after doing so, what you need to do, place this entire thing in an array list or a list. To be more general, put these objects in a list. Okay, so as you have created a new list, some space will be occupied, and that space occupancy will be equivalent to what? Its space occupancy will be equivalent to the number of meetings, that is order of n space will be occupied. Okay, so time and space will be discussing at the end of algorithm. So I have sorted. Now I need to sort the meetings, right? An object, a list of meetings was created. Now I need to sort the meetings. So sort the list of meetings based on their ending time. Okay, so now I have a sorted list of meetings. So now after doing so, what I need, what else do you need? I need a list to store an answer. List to store an answer. Now what else do we need? I need a variable. Over here, this end time was the variable that denotes the ending time of your previous meeting, right? So this end time variable is required. So let's get an end time variable. And what else do you need? Do you need anything else? No, I don't think anything else is required. Now the next step is going to be a loop. I need to run a loop on each and every element of this meeting. So basically now end time, let's say, is initialized to -1. So I will be running a loop from 0 to I is lesser than n. And inside this, what is the condition that I mentioned? That if this condition is satisfied, then and only then I will include the current meeting. What is that condition? So that condition is over here. If the end time of your previous meeting is lesser than the current meeting starting time, then and only then you will be including, right? So if this condition is satisfied, so if what I am doing, let's call the list, let's name this list as meet. Okay, so now if for the current meeting, meet of I, and its starting time, if this starting time is strictly greater than the end time of your previous meeting, so end time, this is my end time. If this is the inequality, if this inequality is satisfied, then I will include the current meeting in my meeting room. So I have created an answer array list, right? Answer list. So what I'll be doing, answer dot push or answer dot add, I will add my current meeting. What I'll be adding, I'll be adding its index. Okay, I will be adding its index. So I've added this meeting in my meeting room, and what else do I need to update? I need to update my end time variable. I need to update my end time variable with what value? With the end time of the current meeting which was included. Okay, meeting I was the meeting which was included, so I will update my end time variable in this manner, and that's it. At the end, what you need to do, you simply need to sort the list of answer. Why do you need to sort the list of answer? Because if you observe in the output, the indexing is mentioned in increasing order only. So if you are sorting each and a particular meeting based on their ending and starting time, it is possible that the indexing will not be in a sequence. It will be randomly selected, and hence you need to sort the last answer list. And then simple, nothing else, the entire algorithm is complete. And this is the entire algorithm. Any doubt till now? Any doubt in this algorithm? Any difficult part, any line you are not able to understand, any part of the logic? Yes or no in the chat box? Okay. If you have any doubt in this algorithm, just directly mention it right now. Okay, thank you, Pratik, for the confirmation. Okay, so this is the entire algorithm. So now let's try to implement in implement in terms of code, right? So over here again, I will be using Java. You can use any of the language of your choice, right? So now I'll be creating an object of meetings, and that object start and idx will be the variables. So what I'll be doing, I'll be creating an object. So I'll be needing a class, and what I'll be calling it, I'll be calling it as class, let's say temp. I need three different variables. I need start time, ending time, and what else I need? I need IDX, that is the index. Let's create a constructor for initialization of this variables. So whenever a new object of this type is created, I will be initializing all these variables with the starting time, ending time, and the index. Right? So I have created an object. Now, what was the second step? Sort the list of meetings. But the first step was to create an object of every meeting and put it inside a list. So now I have an object, I have a class, but I need a list or something like that. So I will create an array list, and the data type of that array list will be objects of temporary class, and let's call this as meet equal to new array list. Now one by one, let's put all the meetings inside your array list meet. So I'll be iterating over the starting time and the ending time. And what else I will be doing? I will be creating an object of meeting or an object of temp, and I will be pushing that temporary object inside my array list, that is meet array list. Okay. So now let's create an object. So I'll be directly creating an object, and inside that object I'll be passing the arguments, the starting time, the ending time, and what else, index. So index, as I mentioned, the indexing is one based indexing. So whatever is the index, I'll add one to it. So this new object needs to be added to your meet. So I'll be adding this object inside my list meeting. Any confusion in this part? If you have any confusion, do mention it right now. Okay, as this is not language specific, everyone, I hope, is not aware, like might be coding in different languages, right? So I have created a list of meetings. So let me add the pointer as well. Now the second step was to sort the meetings based on their ending time. Now I need to sort a list of objects. So now here is the trickier part. Okay, so what I will be doing? So over here we have something called as comparable interface in Java, and you can implement this comparable interface, and inside that there is a compare to method which you can implement it inside the class which you want. So what I'll be doing, I will be implementing comparable interface, and I want temporary class of objects in it. And what else I will be doing, I need implementation of compare to method, like int compare to method, and the argument which I'll be passing to it. This is language specific. If you are not aware, if you are not coding in Java, then don't try to don't get confused by this thing. Okay, and object. I'm passing an argument of object type, and what I'll be doing, I need to sort based on what? I need to sort based on the ending time. So I'll be sorting it based on the ending time. So this thing will help me to sort the entire list of meetings or objects based on the ending time, right? So now I can use the inbuilt method to sort the entire meet. Let's check the output as well, right? And now let's run a loop in order to see the output. Just to show you that this will sort it, let's see the output. This is the starting time and this is the ending time of that meeting. And over here, this is the index. Okay, so let's see the output. And I need to return correctly return this. an empty list. I'm just returning an empty list so that we can see the output, because this function requires something to be returned, right? So I've returned this part. And what is the error? Okay. So are you guys with me or not? Yes or no in the chat box? So whether you can observe the starting time and the ending time. I had three meetings, 1, 3, and 5. They are starting at 1, 3, and 5, and ending at 3, 3, 5. So starting time is 1, starting time is 3. But over here, we are sorting based on the ending time. So this is how it looks, ending time. Let's take this example as well. Let's copy this example. And let's check the output. You can observe ending time sorting has been completed. So now let's remove this and let's get back to our algorithm. So this is going to work perfectly fine. The sorting part is complete. Now let's see what is the step number 3. I need an answer array list and I need a variable end time. So let's see. I need a list called as answer and I need end time variable. Okay, so integer end time is equal to -1 and a list of integer to store the answer, and it is going to only store indexes, right? So now this is the third step, which is complete. And now what is the fourth step? I'm going step by step so that you can understand what actually we are trying to do. And now the fourth step is to iterate over the entire array. Iterate over the meetings. Okay. And now what else I need to check? So what I'll be doing at each and every index, I will extract the starting time and ending time of the particular meeting in a variable. Okay, so mate dot get the element at the ith index, and inside that element get the start time. Okay, integer e is equal to meet dot get I, and I want the ending time, and integer id is equal to meet dot get I dot idx. So I'm extracting all the details of that particular meeting from the object. Now I will be comparing the ending time, that is if the end time of the previous meeting is strictly lesser than the starting time of my current meeting, then I can conduct my current meeting. So conducting a current meeting means making an entry inside the answer array list. So I'll be adding the ID inside the answer array list. And what else we need to do? We need to update our end time variable to the end time of our current meeting. So that updation is also complete. And now this is our fourth step. So fourth step is complete. Now what is fifth step? Is to sort the entire list of answer, because I need the output to be in the sequence of meeting numbers, right? I need it in increasing order according to what is mentioned over here. See, you can observe your task is to, you don't need to read any input output. Your task is to complete the function max meetings, which takes the arrays and returns the meeting numbers we can attend in sorted order. So sorting is required. So I'll be using collections.sort to sort the list, and this list will be answer array list, and now I can return the answer list. Let's compile and run quickly, and let's get this thing done. Was it clear? Can I know from the audience if this was clear or not? So where we are getting 0, 0, 0. Okay, so the reason for that is this part. Let's try to debug why we are getting 0. So we created a meeting. We created IDX. Okay, IDEX. I made a mistake over here. Now let's try to again compile and run. And we can observe compilation works perfectly fine. Let's try to submit and see if this gets accepted or not. So till now, what is the time and space complexity of this approach? What do you think is the time and space complexity of this algorithm? You can try to figure out what is the time and space complexity. This is the creation of a list of meeting. This is sorting part. Okay, so sorting takes n log n. Okay, so let's try to debug, let's try to understand. So this part will, this second step will require big of n log n number of meetings are there. So creation, this part over here, this part takes order of n because you are iterating once. So now this is constant time, this is not going to take any amount of time. Big of 1, this is constant time, right? And iterating over the meetings, what is this? It will be taking order of n, right? And over here the fifth step is sorting again. And what are we sorting? That is, let's say in worst case, what can be the size of this answer list? In the worst case, it is possible all the n meetings can be there inside your answer list. So again, this will be order of n log n. So order of n log n plus order of n plus order of n log n plus order of n. So overall, I can take it as order of n log n. Yes, exactly, Pratik. You are absolutely correct. Sorting is order of n log n. No, Sahil, it is not order of n. Okay. I hope this is clear by now. So the time complexity comes out to be order of n. What about the space complexity? What extra thing have you taken? I have taken only a meeting array and I have utilized this answer array. And the size of both the array at max can be order of n because this meeting array contains all the meetings and this answer array at worst can contain all the meetings. So the space complexity can be taken as order of n. And this is exactly equal to what is expected from the question, expected time and space complexity. How time complexity of sorting algorithm is order of n log n. So the best sorting algorithm which you can think of, that is merge sort, which is also implemented internally in this inbuilt functions, and it will take order of n log n. Okay, Sahil? Okay, do you have other any kind of doubt, anyone, regarding this question? Or else we'll jump to the next question, that is the question which will be given to you in homework. And are you guys doing the practice questions on your own, this kind of questions which the mentor is giving you as a homework? Okay, I see no doubts coming. So let's read down this problem statement. For this question, I will be explaining the entire problem statement and I'll be giving you some hints so that you can try this solution on your own. Okay, and I already taught you the technique to solve questions on greedy algorithm, right? Take different test cases and then you will be able to solve it. Not repeating this question, but still confused. How about how about but how to arrive at greedy solution? See, for greedy, as I mentioned, okay, so again, trying to explain you. See, for greedy, according to my experience and according to the questions which I have solved on greedy and on DSA, generally greedy can the algorithm for greedy can be found by repeatedly working on test cases. Try to create a generate a test case. If you have a test case, try to get the correct answer. And how you will get the correct answer? By arguing that is this the optimal answer. If this is the optimal answer, try to find out a conquering answer, that try to minimize this, try to find a smaller answer compared to what you have achieved for that particular test case, and keep on doing that thing for different test cases, and you will find similar kind of steps which are being followed in solving each and every test case. So that is the way to get the solution for greedy algorithm. Now I hope you are able to understand, Pratik. Okay, and obviously you need to know standard questions of greedy or any of the DSA topic. You need to learn about standard problems as well. Okay, okay. So the last question which I'll be giving you for practice, that is candy. I'm not giving you candy, I'm giving you this question. And try to read down this problem statement. Or let's already we are, it is 9:40, so I'll be reading down the problem statement. I'll be quickly explaining you what the question is trying to say. Okay, so the question difficulty is hard, but it is not very much hard. The solution part, if you will understand, if you will look at it, it's not very much complex. Okay, so there are n children standing in a line, and each child is assigned a rating value given in the integer array ratings. Rating array denotes the rating of the ith child. So you are giving candies to these children subjected to the following requirements. Okay, each child must have at least one candy, and children with higher rating get more candies than their neighbors. Okay, so these are the 2 points. These are the uh, requirements for assigning a candy. Okay, so you have to follow this part. Each child must have at least one candy, and children with the higher ratings get more candies than neighbors. So what you have to do, return the minimum number of candies you need to have to distribute candies to the children. You have to find out what amount of minimum candies I need to keep it with me, so that these 2 points are satisfied for the given test case. So now let's work on this sample example. So over here n is equal to 3, and ratings array, and this ratings array contains 1, 0, and 2. So what are the 2 points? That 2 points are at least one candy for a student. Okay, and the other requirement was student with higher rating. Children with higher rating get more candies than their neighbors. Student with higher rating get more candies than neighbors. Okay, short form NBR, neighbors. Okay, so now this is the thing 1, 0, and 2. So the first point says that at least one candy for every student. Okay, so let's assign one for every student. Now the second point says student with higher ratings get more candies than their neighbors. So let's start with the first one. So 1 and their neighbors are 0. So over here, one should have more candies compared to 0. So over here you can see 0 is having one candy. So in order to find minimum number of candies that you should keep, you will try to not give more or not required amount of candies to any of the children. Okay, so not giving more number of candies which is not at all required to any of the children. So minimize the candies you need to have. So this should have one more candy. So I need a number which is greater than 1, and the closest one is 2, so I'm selecting 2, that is 2 candies. So now let's come to this. So 0, is it larger than both of its neighbor? No, it is not larger. So 1 is sufficient enough for 0. Now 2, is it larger than both of its neighbor? Yes. Over here no neighbor, over here 0. So 0 is already having 1, but 2 is also having 1 candy. So it needs to have more higher candies compared to 0. So the next number which is larger than 1. So I need a larger number compared to 0, compared to 1. So that is going to be 2. So this last student will be given 2 candies. So in total, how many candies are being allotted? 2 plus 1 plus 2, that is equivalent to 4. So the output comes out to be 4. And let's come check it. So over here I'm getting 5 as the output. Okay, so it's 2 plus 2 plus 1, that adds up to 5. Sorry, my mistake. It adds up to 5. 2 plus 2 plus 1, that is equivalent to 5. So 5 candies is the minimum or minimum number of candies that you need to keep with you. Yes, Pratik, exactly. You are correct. Okay. So this is what the question is trying to say. Let's take one more example. Now let's take one more test case number 2. In that, what I'll be doing, I'll be rearranging it 201. Let's say this is 3. Okay. And following the steps according to the question. So this is the step which I need to keep in mind. So 0, 1, 2, and 3. And now the first, at least everyone should have a candy. So assigning 1 to every student. Now the second thing needs to be handled. Student with higher ratings get more candies. Okay, so the first student, let's start. It is having rating 2 and both of its neighbor. So over here no neighbor and this is 0. So 0 is having 1 candy and 2 is also having 1 candy. So it needs to be having higher candies compared to 0. So next number which is larger than 1, it is 2. So 2 will be assigned to this 2. Now next 0. Is it larger than any of its neighbor? No. So 1 is sufficient for him. So for this 1, is it larger than any of its neighbor? Yes, it is larger than this left neighbor. So for compared to left neighbor, it should have higher number of candies. So both of them are having 1 candy. So if I give him one more candy, that is 2 candies, then this second point will be satisfied for this student. Now the last one. So last one is equal to 3. And for last one, what else do you need to do? You need to compare both its neighbors. So left neighbor is not, right neighbor is not there, and left. So 3 is larger than both of its neighbor, right? So obviously it needs to have higher candies compared to 1. So a number greater than 2, which is just greater than 2, that is equivalent to 3. So he'll be having 3 candies. And now what is the total number of candies distributed? 2 plus 1 plus 2 plus 3, that is equivalent to 8. 8 candies are being distributed. Okay. So now was the question clear to everyone? Yes or no in the chat box? A quick reply from everyone whether the question was clear to you or not. Can you show it for a test case 2103? Yes. Yes, absolutely. We will take one more test case. Test case number 3 and 2, 1, 0, and 3. Okay. Following the first step, at least one candy for everyone. 1, 1, 1, and 1. Now following the second step. Okay, so this first student, it is larger than any one of its neighbor, this one. So both of them are having 1, but it should have larger or higher number than this one. So I'll be taking the next number larger than 1, that is equivalent to 2. So 2 will be assigned. So over here 1, is it larger than any of its neighbor? Yes, it is larger than 0, right? And both of them are having same candies. It is not at all uh, acceptable, right? So this will also have higher number of candies, but I want to minimize total number of candies that I should have. So I'll be taking a number larger than this, and smallest one, that is equivalent to 2. So 2 candies will be given to him. Now for this 0, any of its neighbor is smaller than 0? No. And what about this last one? Any of its neighbor smaller than 3? Yes, this neighbor is smaller, and both of them are having 1 candy. So I'll be skipping this. I need a larger amount of candy. So a number just greater than 1 comes out to be 2. So 2 will be sufficient, and this inequality holds true. Student with higher ratings get more candies than neighbors. And what is the sum? 2 plus 2, 6 plus 1. that is equivalent to 7. For this, the output comes out to be 7. Okay, Pratik, was it clear? I hope, is it clear to everyone, yes or no? So that I can give a hint on how to solve this. Not clear? Which part? Can you mention, Pratik, which part is not clear? 2 and 1 both have same candies. Okay, okay, we got it. Yeah, yeah. Thank you for pointing it out. So the second point is not being fulfilled for everyone, right? So 2 and 1 both of them are having same candies. So you can observe over here 2 and 1 are having same candies. So this is not at all sufficient enough, right? So I need a larger number compared to this one. Compared to this one, a larger number which is closest, which is smallest one and larger than this two, that is equivalent to 3. So this will be assigned to 3 instead of 2, and now this is the minimum candies I should have, that is 3 plus 2, 5, 6, 7 and 8, and the output comes out to be 8. Now anywhere else? No, I don't think anywhere else. 1, okay, 3, okay, and 2 and 1. I hope now it is clear. Is it clear now? Okay. So now, what about the brute force approach? Are you guys able to think about a brute force approach? So we recurse on the left if needed. Okay. So this approach, which we were doing right now, you need to apply it more than I don't know how many number of times, right? Because at each and every point, you will be fulfilling both the points for a particular index. Both the points will be fulfilled for a particular index in each iteration, right? So in that terms, you need to apply this loop many number of times until and unless you see no change happening to this entire array, and every time try to pick the, what you will be trying to do, maximum of both the child, left or right child. Okay, maximum of both the left and the right child. So over here, for the particular student array of 5, you have the left child and the right child, right? What you need to do, let's say both of them are greater than the current. Both of them are, I mean, both of them are having less ratings compared to you. Array of I minus 1, array of I plus 1. Both of them are having less rating. So this obviously needs more number of candies. So what you will be doing, you will be taking the maximum of both of them, that what candies are assigned to both of them. So candies of I minus 1 and candies of I plus 1. So maximum and plus 1 is the number of candies that you will assign to current student. Isn't the highest has to have highest can, that means 3? No, it is not the case that highest should always have the highest number of candies. Okay, if over here, uh, see, the comparison is not among the students, not among all the students. The comparison is among the neighbors. I minus 1th neighbor, ith neighbor, and I plus 1th neighbor, right? So the comparison is for the neighbors only. It is not for the total number of students available. Okay. So this is how I can select the uh, proper minimal amount of candies I need to give to the particular student. Okay, so for this, what you can do, you can iterate over the total number of arrays, total number of elements in the array, I is equal to 0 to I is lesser than n. And at each and every time, you if you find this condition to hold true, that I is greater than any of them, okay, any of them, so what you will be doing, plus 1 to the number of candies of its neighbor will be assigned to ith one. And this algorithm needs to work until you see no change inside your array. Until there is no change, until the array remains unchanged in any of the iteration, after that iteration only, you will end the while loop, the outer while loop. Okay, else you will keep on continuously applying the while loop. So that is how the brute force algorithm can be implemented. Okay, so that brute force algorithm will be, let's say, the outer loop runs k number of times and the inner loop runs n number of times. So what will be the time complexity? The time complexity will be k into n, and can be as large as n. So the overall time complexity will be n square or more than n square, right? K value can be greater than n as well. So the overall time complexity comes out to be k into n. Now what about the space complexity? The space complexity is nothing. I'm not using anything for the brute force approach. So space will be constant over here. But time is very much, it's exponential. I mean, not the, it is quadratic. Order of k into n. Okay, so this approach might not work if k is equal to n. If you observe what is the maximum possible number of n, it can be as large as 10 to the power 4. So n square will be 10 to the power 8. And it is possible that 10 to the power 8 number of iterations are not acceptable for this question. Okay, write the algorithm name. This algorithm does not have any name. There is no name of algorithm. Okay, so this was one of the brute force approach. So now what, guys, what you can think of? So this is my hint for a better solution. What you can think of, target on left neighbor for every student, target on left neighbor, sort out things with the left neighbor first, and then you can sort out these things with the right neighbor. Okay, that means target on the left neighbor, it means that what I'm trying to say over here, the second point says student with higher rating gets more candies than their neighbors. So that's this statement will be changed to student with higher ratings get more candies than its left neighbor. So that is sorting out the things with left neighbor, and sorting out the things with right neighbor means student with higher ratings get more candies than the right neighbor. Okay, so I have divided the entire question into two different segments, two different parts, and if you solve for both this part, you will eventually arrive at a minimalistic number of candies. Okay, Naman, the session is almost over. Okay, so if you focus on this thing, that sorting out things with the left neighbor first and then sorting out things with the right neighbor first, this is going to help you to think on the. So let me give you an idea about target on left neighbor, sorting out things with left neighbor. Let's understand what it means with the help of test case 2103. This is 2103. Now I will make sure that each and every student has who has the higher rating compared to left neighbor, he should have higher number of candies. Student with higher ratings get more candies than left neighbor. Okay, than the left neighbor. So this is sorting out things with the left neighbor. So the first point needs to be handled as it is. 1 1 one. Everyone gets one candy. Student with the higher ratings get more candies than the left neighbor. So each and every time I will simply compare with the left neighbor. So 0. Does it have a left neighbor? No. 1. Does it have a left neighbor? Yes. So I need to check whether this is having higher rating than the left neighbor or not. So do you think 1 is greater than 2? No. So this is not having a higher rating. So now the next one, 0. So do you think 0 is having a higher rating compared to its left neighbor? No. So it does not have to have a more number of candidates. Now what about this 3? So do you think 3 is having higher rating than 0? Yes, obviously 3 is greater than 0. So sorting out things with the left neighbor, that means this left neighbor has one candy. So obviously this 3 needs to have higher number of candies. So next larger number after 1 will be equivalent to 2. So this will have 2 number of candies. So same similar to this, let's sort the things with the right neighbor. 0, 1, 2, and 3. This is 2, 1, 0, and 3. Okay, so starting with this one, does it have a right neighbor? No. And each and every one initially will be assigned one candy according to the question, at least one candy for each and every student. So this one. So 0 is greater than the right neighbor? No. So leave it as it is. So 1 is greater than the right neighbor? Yes. So it should have higher candies than the 0th neighbor, right? So plus 1 to it. So this will be equivalent to 2. So now coming back over here. So 2 with its right neighbor. 2 is having higher rating compared to its right neighbor. So a number should be greater than 2 with himself, right? So 2 plus 1 will be equivalent to 3. So 3 candies will be assigned to him. And now this is the current number of candies. So now with the help of this data, try to think how you can achieve the finalized solution. This was the hint for the optimal solution. Was it clear to everyone? Yes or no in the chat box if this makes sense? Okay. Any doubt, anything from your end? If you want to ask anything, you can ask it right away. Yes, and those of you who are trying to solve this question, the last question, let me paste down the link of this as well. And put down your solution in the comment section, and I'll be happy to read down your approaches, right? If you have any kind of different thought process, or if you are able to figure out the solution with the help of this hint, do mention it in the comment section. Attach a link of your solution. I will write it down, okay? Okay, so do you have any kind of doubt? You want to ask me anything or anything? Then you can ask it right now. I'm here for 5 minutes, and then we'll end the session. Sir, for greedy, do as many questions as you can. No, it's not the case for any of the topic or any of the topic of DSA. It's not the case that you need to solve as many questions as you can. The target should be, you should know that why you are studying DSA. You are studying for interview or you want to do competitive programming. So there are completely two different paths. Interview centric path, then you need a perfect or a different strategy to look at DSA. Okay. So you need to focus more on understanding standard algorithms properly. And you need to focus on solving SD sheets as well. Okay. I I have been giving guidance to students regarding how to prepare for DSA. I have been telling to everyone that focus more, understand more standard questions, right? You should have a better understanding of standard questions for every DSA topic, because everything revolves around standard questions in interview. And for CP, there's a completely different approach, right? You need to know many different algorithms. You need to increase your speed. You need to try out as many questions you can, right? It's all about practice. So over there, do as many problems as you can. Works perfectly fine. But in a specific manner, not randomly choosing any question and just starting to invest some time on it. Okay, 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 Pratik. I hope you guys enjoyed this session. If you really enjoyed this session, then do like this video and then share it with your friends as well, right? And to comment down in the comment section if if there are any kind of views regarding this video. Okay, and do solve the last question. It's very interesting and you will enjoy it a lot. Okay, so let's meet tomorrow. Apart from DSA to get SD, what are the things you need? Apart from DSA to get SD, okay, so apart from that, you need a good communication skills. Like, at least if you are not fluent at English, it does not matter, right? If fluency in English does not matter, it matters that are you able to express your ideas, right? That is the other person able to understand your ideas or not. That is one of the thing. Communication or expressing the ideas and working with the team is one of the non-tech thing which you need to have, right? You need to start accepting to work with the ideas of other people. And other else apart from that, projects are required. If you are asking about technical part, projects are required, right? At least few basic projects that says development. Okay, so for technologies, whatever role you are applying for, mention it inside your resume. You already know what technologies or what are they expecting from the candidates. So for technologies, you can do that thing, and for resume shortlisting, use keywords. And for keywords, you can look into internet, or there will be many articles available that how to make your resume shortlisted by the algorithm, which uh, filter out the resumes, right? So for that, you can do that thing. And project building projects should be written, and there are many method of writing down the resume, right? So you should completely focus on keeping your resume short and crisp enough. My third year finishes Wednesday. I'm planning to learn computer how to get started. About yourself and work means, my third year finishes Wednesday. I'm planning to learn computer program how to get started. So the first thing is to learn about DSA. If you don't know DSA, go focus on DSA. Understand every topic of DSA to standard problems. There will be around 250 to 300 standard problems. Get it done. Understand all of them properly. After doing so, now you can shift to practicing DSA questions. Okay, but after getting a practice on DSA question, at least 200 questions more, after that you can start competitive programming. That's what I suggest to everyone. Okay, so my name is Yadal Sanya, and I work as a mentor at Geeks for Geeks, and I have been teaching students, and I have been into edtech from past 2 years, and currently I am working over here as a mentor. Okay, Gunna. So now I think we should end the session here only. It was great interacting with everyone, and I hope everyone enjoyed this session. And do share it with your friends, and do attend the upcoming sessions. I will be taking the live session for tomorrow as well. I hope this session was not at all boring. Did you guys found the session to be boring, or was it entertaining? Apart from teaching, what else I do? Okay, so what apart from teaching in terms of uh, job or profession, or what else? And if you have any kind of doubt, you want to connect with me, you can connect me on LinkedIn as well. Okay, so I think it's time we should end the session here only. Bye bye, everyone. Good night, and practice the last question. So, list of standard DSA questions can be found. I am working at Geeks for Geeks, Purna. That's what I mentioned. Apart from teaching, that is my profession right now. Okay, so where to get standard DSA question? You can take any of the website. You can look, you can write down, you can Google it. Standard questions on DSA in GFG. Over there, if you will focus, or if you will say greedy algorithms, you will get a list of standard questions, easy questions, medium, and hard. Do the standard ones. Okay, over you. Okay, so bye bye everyone. Good night. It was great interacting with everyone. Let's meet tomorrow. Bye bye.